on behalf of VDOT. Excited to be here talking about this project. Glad to see the excitement in the room for the project. If I get a quick anecdote about myself, grew up in small town Pennsylvania. My parents told me three things: always eat a good breakfast, be respectful to others, and never present in front of a room of rocket scientists. So I am 2 for 3 today. So again, thanks for having us. I am a civil engineer by trade. Any other Yellow Jackets in the room? Yes, my family people. On the construction side, there's not too many of us. There's a lot of Hokies, Cavaliers, but yeah, thanks for having us today. We'll jump right in. I'll power through some of this stuff. There's a lot of information to get through. We do want to save some time for questions, so we will certainly circle back to questions at the end. So I think most people here in the room certainly are probably familiar with the HRBT. I have something I call a Hampton Roads lie detector test. Who has never been stuck in traffic at the HRBT? You all passed. Good job. But it is more than just a tunnel project. Really, it's a 10-mile corridor from Mallory and Hampton out to close to 564 in Norfolk. If you've driven through the area, you see more than just that going on. We are part of a network of express lanes that are coming to the region that will extend from Jefferson and Newport News all around 64 to Bowers Hill. So a lot of different projects coming on. It's hard to know where one project starts and another project ends. But for the tunnel, again, we are about a 10-mile project. The scope of the project is, besides just the new tunnels, the entire corridor will be expanded to 4 lanes in each direction. 2 lanes will be general purpose lanes, and the other 2 will be managed lanes, tolled managed lanes with the express lane model. So if you have a HOV with a flex pass, you go through with no toll. If you're a single rider, you can choose to pay the toll. A couple stats that I'm contractually obligated to go through. So we awarded the contract in 2019. Notice to proceed in September 2020. Really, that gap is pretty important. During that time, we did go through our environmental permitting process, which was a large risk on a project of this size and the different impacts we had within the waterways. So that was a interim step to be sure that we could procure all the necessary permits, which we did within that time period. Project cost $3.9 billion. It is a design build project. I think probably most of you are familiar with the design build delivery model. And then project funding is very unique for a project, especially of this size, but only 8% of the funds are state and federal funds. 92% come from our regional gas tax. Here that's administered through HR TAC, Hampton Roads Transportation Accountability Commission, who collects sales tax in the region, which is used for large projects in the region, the 64 widening up towards Williamsburg, high-rise bridge, those types of projects. So pretty unique funding on a project, especially of this size. For our project partners, VDOT is the owner. We will own the facility when it's done. It is not a operate, maintain model with the concessionaire. VDOT will be the owner after the project. Again, HR TAC is our funding partner. And then Hampton Roads Connector Partners, we call them HRCP. They are a design builder. They're a joint venture of Dragados, Vinci, Doden Campion, some large, and Flatiron, some large international firms with tunneling experience. Also, our designers is a joint venture of HDR and Mott McDonald. So those are the main players on the team. So what makes HRBT unique? This is VDOT's first bored tunnel that we've ever done. If you're familiar with the other projects in the area or the other tunnels in the area, all of our tunnels were all built with immersed tube tunnels where you fabricate the tunnel sections on land, dig a trench, immerse them in, backfill them, connect them, all that. As part of the design build process, when we actually put this out for procurement, we did not specify the type of tunnel that we required. We let that up to industry, and the bored tunnel became the option that the industry came to us with. So with that, we are in the bored tunnel industry now. The bored tunnel that we're building here will be the second largest bored tunnel, roadway tunnel in the U.S. The only one larger is in Seattle, the Big Bertha project. They actually have a double-decker bored tunnel. This is only the third bored tunnel in the U.S. for vehicles. The other one after Seattle was Port of Miami, built a bored tunnel. So you're probably also familiar with Chesapeake Bay Bridge Tunnel. They're also boring. They're in the process of boring their first tunnel. So they're right behind where we're at. Really, one of the main reasons that it was chosen was the impacts of the navigable waterways. Obviously, here in Hampton Roads, home to the largest Navy base in the world, deepest port on the East Coast. It's very important to maintain the channel out there, and that would have been extremely difficult with immersed tube tunnel. So, given the technology advances with bored tunnel technology, we have soft soils in this region, but again, that did become the selected alternative to build the new tunnels. So what's in the name? We do name our TBM. Our TBM is named Mary. It's traditional for boring machines to have female names after Saint Barbara, the patron saint of mining. We did put out a contest to the local school children to name the machine, and the selected name was after Mary Jackson from the movie Hidden Figures. Anyone seen the movie Hidden Figures? This is my audience. Thank you. The response isn't always that overwhelming. So you all know the story of Mary Jackson. So she is the namesake of our TBM. The cutter head. Does anyone know we had a Hampton Roads flag? Maybe less response on that one, but we do. All the stars represent our member localities. The blue for the ocean, the land for, or the green for the land. So that's what the significance of the cutter head. So again, this is the second largest TBM in the U.S., 46 feet diameter, 430 feet long, 4,700 tons, 9.8 million pounds. So it is a massive machine. The picture there in the upper left, that's actually the TBM at its facility in Herrenknecht, Germany. That's where it was built, fully commissioned, disassembled, shipped to the United States, reassembled for use here on the project. So what is a TBM? The tunnel boring machine, and how does it work? There really are a couple different types of TBMs. The first tunnel boring machines went through rock. We obviously don't have a lot of rock in this area. There's earth pressure balance machines. There's slurry machines. Each have different capabilities. Our machine's relatively unique. It's a combination of the two. It's a variable density. So kind of walking through this graphic, on land, there's a slurry plant that produces slurry mixture of bentonite water that's pumped to the face of the machine, that's injected into the surface twofold to harden and then also, liquefy some of the material that comes out. The material that's excavated, the cutter head in the front rotates, excavates the material, puts it back through a series of pipes, and sends it back up top to the slurry treatment plant, where the material is recycled. We pull out excavated material, recycle the slurry, and put it back. So it's really a continuous system that moves along. The other piece we can highlight here is you see about the middle, there's some hydraulic cylinders in there that are just ahead of the gray rings. So to build the tunnel is a series of rings that are made up. Each ring is made up of 9 segments. So the way the machine actually advances is as we build a ring, the cylinders will push off the ring behind it, retract, we'll build another ring, push off, retract, build rings. So it's really that process over and over. Each ring is about 2 meters long. So that's how the machine advances. Sort of a cutaway of what the existing tunnels look like on the left versus the new tunnels on the right. You can see they are deeper than the existing tunnels. Really, the channel will always be limited by the existing tunnels. So really the reason for going deeper is the machine likes to dive down to the more compressive soils. So it dives down, gets there, bores, and then goes back up. You also see slight curvature away from the existing tunnels. That was just to minimize any risk of impacts to the existing tunnels. This is the interior of the tunnel. The new tunnels will have, you can see on the left side, egress corridors. That would be the event of emergency within the tunnel. There's spaced doors within the tunnel that motorists could evacuate into that corridor and move out. That is a fully pressurized tunnel, so if a door were open, it would not allow smoke to come in. So a pretty advanced system there, similar to what we did build at the new Midtown Tunnel. And then there will be in that space above jet fans for a longitudinal ventilation system, different than the existing tunnels. The existing tunnels have transverse where um, fresh air comes in the bottom, gets pulled up into the upper air duct and pushed out both directions. So this will be different than that. There'll be large jet fans within the tunnel. So looking at progress, so we're starting on the north side in Hampton. This is Mallory Street. It's a kind of project where pictures don't stay current very long. This is one of those. We did in the top of the picture is the Mallory Street Bridge. We are fully replacing that. So the half closest to the camera here was recently opened to traffic, and they're demoing the old half to be able to fully widen that bridge. This is the north trestle, again on the Hampton side, eastbound. Earlier this year, we did put traffic on this new portion of the trestle. You can see ultimately this will lead into the new tunnels. Upper left there is a temporary trestle that puts traffic back into the existing tunnels in this temporary phase. You can see the bottom, sort of the pinch point of why we had to put traffic onto that tunnel, onto that trestle to build the rest of the bridge. We'll have to demo the existing bridge. So we are fully replacing all of the bridges leading up to the tunnels. So with that comes some pretty complicated phasing to be able to maintain traffic. You can see some of the stats here, just the sheer amount of work that goes into building those bridges. And the note there, really, this is the first time in over 50 years that we've built a new structure out there to put traffic on. So those structures have pretty much met the end of their service life, or they would have in the next 20 years required significant rehab. So we are replacing them as part of the project. Going to the North Island. This is the one closest to Hampton. You can see Fort Monroe there in the background. We did expand the size of this island. We more than doubled the island to be able to receive the new tunnel. Moving to the South Islands, this is really the home base of operations for the tunneling. The bottom left of that picture is our slurry treatment plant. Again, that's where all of the material is recycled that comes out of the tunnel. The spoils are separated to put on a barge to go for disposal. So this is the shaft. So really to start, we had to build this large shaft because the boring machine needs pressure at its face. So we couldn't just start from the surface and dive down. So by building this shaft, we're able to lower the machine into it. We actually did ground improvement ahead of it to be able to give it some solid material to bore through. And this was the launch of the boring operations from the South Island. The South Marine Trestle moving towards Norfolk. This is going to be a large 8-lane structure. That's my bad. Mute. So again, large structure going into Norfolk. We are planning on shifting traffic onto this structure next year. I call this an engineer's Rorschach test. Depending what kind of engineer you are, you see different things. I'm a traffic engineer, so I see all the traffic stopped right there on the bridge leading up to the tunnel. Then they zoomed in on it for me to add stress. Really, this shows, and this is the westbound tunnel, but you can see the temporary bridge to the right there that we're building so we can put traffic there to be able to demolish the existing portion of the bridge. On the left, that's the eastbound. We did that same thing last year, put traffic on that temporary structure to be able to build the existing structures. That's one of the large challenges of this project. We're landing all these bridges at the existing area, so we got to move everything out of the way on temporary structures just to be able to build permanent structures. So again, complicated phasing that we're working through. Then on the really landside progress, again, we're widening everything. One unique aspect of this project is we're doing it without acquiring any new right-of-way. So it is a very constrained corridor. We're basically building everything to the median, taking up the median with barrier, rehabilitating all the bridges in the corridor. So really, all this landside work would be a large VDOT project by itself. But combined with the tunnel, a lot of coordination going on. Again, all the various bridges in the corridor getting rehabilitated as well as widened. So as far as the mining and the tunneling, we commenced the first bore again from the South Island. Started last year. So each bore takes about a year evolution as it advances. As I mentioned, the each tunnel is made up of rings, 1,191 rings. Each of those rings is 9 segments. The picture on the right is our segment erector. It's really vacuum. It picks them up with vacuums, moves it around, puts it into place. They're bolted in position, and that's how it builds the ring around it. On the left, you can see all the segments stacked up on site. They're all cast up in Cape Charles on the Eastern Shore and barged down to the site. Bottom left is our multi-service vehicle. That's the little car that moves the segments into the tunnel to feed them up to the TBM. So again, we have that process of pushing off, building a ring, pushing off. So really progress is normal is about 50 feet per day. Some limiting factors there is after boring, we got to put the material up. Takes time to process those materials. Also because they're all barged off, if there's weather, such as today, even with the winds, any type of craft advisories limits the movement of barges. So we only have about a day's worth of capacity to store materials there before we kind of become, we call muck bound and unable to move more out. So it's really a delicate balance of boring, processing, removing materials. But you can see some of the stats of some of our production. So with that first evolution, we got to April earlier this year for our big day, as you can see here. With dramatic music, I'll turn it up. So you can see that slurry material behind it that's constantly used in the process. And so it was the breakthrough of the first tunnel, which officially made it the first bored tunnel in Virginia. So once we broke through, you can see the person there kind of get some sense of scale. It's a big machine. So now we had to turn it around to go back the other way. So that created the next challenge. So we use some technology that's been used in Europe before, but this is the largest use of it. The bottom of this picture, that's what we call a nitrogen skate. So really on that cradle underneath, there's some rubber bladders that we injected nitrogen into, and then that on the bottom surface, steel plates that they lubed up with oil. So really what happened is once they did that, you can see those pulleys were actually able to pull the machine around into place. So it reduced the friction just enough. So I kind of think of this combination of an air hockey table and then also the little pads you put on your sofa to be able to push it around. Kind of a combination of those two. We're able to actually move that whole structure around. So this is a time lapse of what that looked like. And really this all happened in one 8-hour shift. It was pretty impressive how they did it. And again, this is the largest piece of equipment they've ever used with this type of technology. So turned it right around and put it into place. So Next in line, each of the gantries behind it are being one by one pulled out. Because they're so large, they can't turn them around in the pit. They actually use cranes, bring them up to the surface, turn them around there, lower them back down, put them in line. As of this week, we've turned around 3 full gantries and pulled the 4th gantry out of the tunnel. So as of this week is the first time we have a clear path from one end of the tunnel all the way out to the other end, laid at the end of the tunnel, literally. So a couple other things we found here. So this is where the interesting stuff starts. Everything before this, maybe not as much. So the 3 barges, we'll get to what those are that are pictured there. So this project, you're probably familiar with federal contracts. Civil rights goals are included in all of them. Typically, it's a percentage of a project, and it's no different here. The one difference here is just the size of the project makes those percentages a really big number. But we are meeting all the goals that we've put on this project for civil rights, so I'm proud to say that. Environmental challenges, I talked early on about the need to acquire some of the permits. One of the unique things here is the South Island, which was built in the 50s when the first tunnel was built, connected to Fort Wool, which is kind of a small area out there. But after the island was constructed, we started getting a migration of colonial nesting birds. The South Island turned out to be, it is the largest nesting location of colonial nesting birds in the world. So that became an issue, and that anytime one of those birds would lay an egg, we have to set up exclusion zones. It slows down work. So working with some of our agency partners, we did come up with the plan to use those barges just off the project connected to Fort Wool. Those are filled with sand to become sort of a second habitat for those birds. To help encourage them to that spot, we've used the border collies, which you see in the picture here. They've kind of become our unofficial mascot, but similar to airports use them, golf courses, just sort of they chase them around, they don't hurt them. But it's been extremely successful. We've had very limited eggs, and those have all kind of shown up in places that are out of the way that don't get a lot of traffic. So very successful project there, both with working with our agencies and implementation. Marine noise impacts, again, you saw the numbers on all the piles that we've driven in the water. We do have sensitive marine animals, so a lot of mitigation strategies. One, we use actual bubble curtains around those piles to kind of dissipate the noise impacts. And other protected species, turtles, sturgeon, lots of things that we're on the lookout for as we build the project. So a lot of environmental challenges. Artifacts, obviously we are site of some key Civil War battles, Battle of Hampton Road. So on our South Island, which was really built out of fill from the channel a long time ago. As we were constructing the slurry walls and digging that pit, we encountered a number of cannonballs. So as we find cannonballs, we call the unexplored ordnance teams. They come in. We do have 2 of those cannonballs on display at our visitor center, which is off of 4th View in Norfolk, which isn't officially open yet. We're getting very close to opening. Those are the 2 that didn't need to get exploded. The other ones actually did get exploded by the ordnance teams. Also, as we were dredging for the North Island expansion, we encountered these timbers. They turned out to be historic as well. William and Mary did a study in them to figure out what they are, when they're from. So they dated it back to 1819. There was quarried rock around it, which they were able to match up with Fort Monroe. So they sort of know where it was going to. They figured out somewhere far up the Chesapeake where it was quarried from. So again, William and Mary did a pretty good study on that. If you're interested in some of the archaeological pieces that we found, that's a good study. And then the one that nobody had on the project bingo card going in, you probably all know, you go through all your risks. What are the possible risks? So as we were mining last summer, again, the material goes through the machine. Once it gets to the slurry treatment plant, it kind of goes up a conveyor. There's some magnets on there to pull out any metal debris, other things. But as they were mining, someone spotted something that looked a little different, and it was mastodon bones. So, so again, working with the agencies, they were able to identify what they were. There's a couple of different pieces, again, that we have on display at the visitor center when it opens. But this is, we're told, the furthest east they found these bones. Again, there's probably more down there. These were over 100 feet under the ground, below the river. So really in some soils that haven't been disturbed for at least 50,000 years. But that was a kind of interesting find and not the one that we expected on the project. So that is the end of the formal presentation. We do have some ways to stay connected to the project if you're interested. You can sign up for the newsletter. We also have printed newsletters here in the back if you're interested to take some away. We do have some time for questions. Also, we talked about how the machine advances. I didn't really talk about how the machine maneuvers and turns. Obviously, there's not a big old steering wheel at the front of the TBM. So really, all those rings are made up of the 9 segments. Each segment has a unique geometry to it. So depending how you order those segments in the ring changes the face of the plane. And that's really what the machine pushes off of and turns. So if you guys want to come up afterwards, we sort of have a representation of that. And depending how you align these different things, it turns one way or the other. So this is kind of the concept of how the machine actually moves and turns both horizontally, vertically. The other piece I probably didn't mention is the project completion is currently February of 2027. So making progress. Again, we just turned the machine around. We do anticipate starting boring operations again, probably towards the end of October, and then it's another year to progress to the other side. So that takes us to later 25, and really everything that happens between 2025 and the end of the project is outfitting the tunnel with all the various systems, mechanical, electrical systems, pumps, fans, lights. So a lot of work to do once we bore through. That's just the beginning of the fun.